Mathematically, when we're talking about the domain and the range, we want to represent it using an inequality sign. Because for the most part, we're going to be talking about continuous functions, which are functions that are continuous over a certain period of time. And over that period, we want to be able to explain what the domain and what the range are. Now remember, the domain is the x values, the range is the y values. If we look at the first graph, we can see we've got an open dot on -3 here, and we've got a closed dot on +3, and I'm just talking about x values. The open dot means that -3 is not included in the domain. The closed dot means that +3 is included in the domain. So when I go to list the domain, I'm going to list everything, so not including -3, everything to 3, including 3. Now, there's two different ways we're going to list them. If it's inclusive, we're going to use a parentheses. If they are both, I said that backwards. If they are exclusive, meaning we have an open dot and they are not included, we use a parentheses. If they are inclusive, which means they include it, we use the brackets. Now if we have one that is inclusive and one that is not, we use one bracket, one parentheses. So if I look here, I have 1 point, which is -3, that is not inclusive, meaning -3 is not included. I want to put a parenthesis. And for my for the other side of my range, I'm going to use +3, and I know that one, since it's a closed dot, is inclusive, so I'm going to put a squiggly bracket. So this tells me that my domain is -3 to 3, where 3 is included, -3 is not. And now remember, that's just my domain, which is my x coordinates. If I look at my range now, my range is my y's. So I can see from the y's it goes from -3 all the way up to +3. Now +3 is the one that is not inclusive, -3 is inclusive, and we always want to put these in numerical order, so we'll put -3 first. Since it's inclusive, we'll put a squiggly bracket, and since +3 is not inclusive, we just put a parentheses. And so that tells me that my range is all of the numbers between -3 and 3, including -3, excluding +3. And we could tell that between the parentheses or the squiggly brackets. Now if I look at my next example here, my next function, this one's a little bit different. This one ends with arrows. Ending on the arrows, we can assume that those arrows continue in that direction forever. So, first thing we want to look at is my domain. My domain, we can see here the minimum value for my x is -2. So I'm going to put -2 as my minimum value. Now, there's no open circle here, so -2 is inclusive, so we're going to put a squiggly bracket. Now you can see here in this direction, this arrow is going to continue that way, this one's going to continue that way. It'll eventually approach positive infinity in the x direction, so we are going to represent that with our positive infinity sign. So my domain here says that my domain, or my x values, are all the values from -2 to positive infinity. If I look at my y values now, my y values, we could see this arrow is going to continue in this direction, this arrow is going to continue in this direction, so we're actually going to have negative infinity all the way to positive infinity for my y values. So my range is all real numbers, while my domain is all numbers between -2 and positive infinity inclusive. And now that's just kind of an advanced way, a better way to write your domain and range so that you don't have to list a whole bunch of different numbers. Now, from this we can also write graphs. If I know that my domain goes from -2 inclusive to 3 exclusive, and my range goes from -4 inclusive to 5 exclusive, I can write a couple different graphs if I want to, but we're just going to come up with one certain situation here. We're going to say this graph. So we're going to look at my minimums here. My minimum in my domain is at -2, so my minimum x is at -2. My minimum range, or my negative y, or my minimum y is a -4. So we're going to put this right here. Since both of these are or equal to signs, that means it's inclusive. We put a colored in dot. Now my upper bounds are both exclusive, which means they're not including these numbers. I've got 3 in my x value and 5 in my y value, so we're going to put them just like that. So it's an open circle, and then really my function can be anything. It can be a straight line, it can be a squiggly line, it can be anything, but it does have to follow these parameters where my domain or my x values are between -2 and 3, and my y values are between -4 and 5.